Here's the setup with a Yagi. I recommend packing lunch. It's usually an all-day event. Other methods include actually sniffing. We're going to talk about that later. Currently, my scripts are written in Perl. We're going to be working on there's new stuff. There's stuff out for Windows called NetStumbler. I'm sure many of you have seen that. If not, we'll run it a little bit later. And there's also more programs coming out for FreeBSD. The way to do it is really trivial. Anybody with a Windows machine can actually just detect networks walking down the street. Put the card in, set your SE to any, run the client manager, and next thing you know, you get this window. Standing in downtown San Francisco, here are 6 open networks I have access to. This is just literally a main street, downtown San Francisco, on a street corner. Detection methods, well, you walk down the street. Let's get some interesting stuff here. There. This is a map of San Francisco. Each of the names you see, there's a separate wide open network. Literally, all you need is a laptop and a $60 wireless card. You stand on any street corner in San Francisco, and you'll have wireless access. I drove around London. Drove around Soho, for example. Every other block in Soho in London has an open wireless LAN. In fact, one is called Britney Spears. So if you want to have fun, it's right down the street from the Intrepid Fox. Listen, have a few pints, have fun. Here's another drive in San Francisco where I concentrated more in the multimedia area. There's 120 points on this map. And that's literally a 1 square mile area at 120 open networks anybody could walk up and use. In this case, we drove around the more residential areas of San Francisco. Again, more networks we know what to do with. What you'll find is when you drive around, if you actually try doing this, what you point out is you'll find networks where you don't expect it. That is, when I went to the low-income areas, I found a lot of open networks. When I went to the very high, ritzy, overpriced areas, I found very few networks. I figured it'd be the opposite. People with money might have wireless networking. No. What happens is people like us go and get cheap apartments. Then we can spend the rest of our money on hardware. Here's actually Sunnyvale, San Jose, where all the .coms and .flops are currently. Lots of, literally, all these are wide open networks. Driving down the street, my machine beeps twice a minute, finding a new network. So, anyways.
Well, you're ready?
Well,
finished?
I didn't want to hog the entire talk.
Yeah, okay. In Germany, we didn't find that much open networks, but we do have. Oops. Okay. Oops. No. Okay. This is our application. It's a Perl TK script. Basically, just do all the detection and the plotting stuff at once. This is the map of the center of the city of Munich in Germany. We got it from nice CDs from the Vermessungsamt, which you can use, which you can get in any bibliothek, in any library, and get nice pictures of the city. The red line is actually where we drove with the car around city, one full circle mostly, and the colored dots are in the networks. The program is a little bit interactive. If you move the mouse over network, you see the network name. This is a hotel Holiday Inn. The interesting stuff is there are lots of networks, open networks, and actually if you stop and look what's inside the network, some of them are easily identified, open with a default gateway at Cisco, which broadcasts any OSPF frames or something like that. And then you have basically 2 Mbit free internet access on a green field nearby. We drove around the city with basically a small FreeBSD laptop, a small GPS from Garmin or from Magellan, and an external antenna. Ray, where is it?
This actually is not the antenna with which we drove around. We used an omni antenna. This one is a directed antenna. But of course, using the directed antenna, you can better scan where the actual network is. Driving around with the omni antenna, you just see, I've got a network, but it's somewhere around here. Here you can really see, oh, it must be over there. So that helps identifying what you are currently targeting.
We have some network over here, which actually, it's not on the map, on top of the map, which actually broadcasts, which an incredible amount of area. You can see this hotel air network. We don't know where it is yet because we didn't have the directional antenna with us, but we suspect they might use more power than they actually should.
Actually, you should talk to me about that later. In my software, I actually have some stuff, not trying to compete, but in my software, actually, we do triangulation based on signal strength. So as we drive around, we actually take samples of signal strength as we go down the street. And if you drive down 2 separate streets and get samples, what we do is we average out the signal, and actually gives us a triangulation point to where the AP probably is.
No, we didn't do that yet.
I'll give you the code.
Okay.
We're logging the strength. I think we're logging it. We're just not using it for the plot so far.
Yes, we're logging the signal strength of each hit and each of the GPS coins along the way. So we could probably use the code to.
Yeah. Well, you do just convert your log format into my log format and run through my code.
Yes, something like that.
Yeah.
We didn't know there were so much people doing that already.
Yeah.
We should do that.
Okay, when you're done, I'll get some statistics to show them.
What?
Oh, statistics.
So that's good. Then do some statistics.
Okay.
By the way, feel free to interrupt us at any time with questions.
So as we see that there, finding networks is not a real problem. The real problem is what to do about it.
Okay. Now, another question people are, how wide open are networks? Well, I'm still in the process of distilling my data. I found that, well, right now I have 2,500 APs discovered. At the time I wrote these slides, there was about 1,500. 60% of the access points are default configuration. That means no password or default password, default web keys, easy information. If you read one of the reasons for this, if you read the manuals for Lucent, for example, they mention how, if you don't understand this, don't change anything. So people are actually in the manual told not to change the settings. Yeah. A majority are connected to internal backbone networks. I've driven down the street seeing router broadcasts, BGP broadcasts. You want to destroy a company? Feed them some bad BGP routes. It'll take them weeks to figure out what's wrong. A majority of these, 85 or more, do not use web. We all know web's easy to crack, but you might as well use web to slow the person down. Most people don't even bother doing that. Those using web use a default web key. Default web keys are 11111 or 10, 11, 12, 13, 14. Try those. You'll get in the majority of the time. What are the most common SIDs? Well, all these SIDs you see up here are default ones that come with the product. Tsunami, for example, is the default for Cisco. Airwave has, Airwaves. Waveland Network are basically going to find on Apple Macintoshes. WLANs, I forget who they are. Linksys is obviously Linksys. By the way, anybody here have a Linksys AP? Just don't want to admit it. If you ever see a Linksys AP, they don't take passwords. You can't even set a password. So it appears that 80% of these things run in default mode. While we're sitting here, people wonder if some other software. Everybody familiar with NetStumbler? This is a Windows application. I did not write this. I wrote some scripts under FreeBSD. Somebody saw what I did and said I could do that under Windows. This is a live demonstration of what's going on a wireless network. So from where I'm standing right now, I'm detecting all these different APs. We have filters. Gets the idea of signal strength. If a GPS was hooked up, we'd actually have latitude and longitude also. And if you wish, for example, you can double click on it, that gives you signal strength. All this is being logged into a file for later. They actually support my log format too, so you can actually run NetStumbler and pipe it through the shell scripts that I have. But effectively, You click on, this is everything you need to drive around. You run this program with a small antenna on your on your car, and we just literally drove around with this laptop, this small little antenna, around London and found 200 networks within an hour and a half. Half of them are in Soho.
Okay, the rate for Berlin that we have is about one network an hour, so we are way behind the curve. Okay, so if there are questions on technology and how to find networks, we should feel that now so that we can move on to the what to do with an open network that you have found part then. So if you have questions on technology, finding networks and stuff like that, then feel free. Okay, that should be, take the microphone.
Test. These gold cards, they have encryption, right? Can you hack them?
That encryption business is quite volatile at the moment. There is a paper from known cryptographers that have done the VEP analysis, and about a week later there was a paper about the implementation for the analysis. So at least there's one set of code out there that can defeat VEP in a passive attack mode. At this moment, I haven't seen any code in the wild, so that means on the network. But with that Interseal-based cards, that is the Prism chipset, that is not the one from Lucent, you can get the raw frames from the network into your system and lock them and do your cryptanalysis on them. And so, okay, it's a little bit pity that we all bought Lucent cards 1 year ago, so probably you will all know buy Interseal cards, but okay, that's live. And so we can safely say that in 1 or 2 months there will be code out on the net that does VEP encryption breaking, so don't rely on VEP. So what we have found in Berlin, for instance, was a huge number of hospitals that had their internal networks on wireless LANs unprotected, completely unprotected, and that faced us with some serious ethical problems. So normally we would say, okay, if someone is announcing his network across the street and giving everybody internet access, so fine, why should I care about it? And but with hospitals, we are in a completely different domain. There's personal records and medical data that can be accessed and manipulated, so we needed to do something about it. And we tried to talk to the people in the hospitals, and it got a little bit difficult because nobody really wanted to acknowledge that they have a problem there, and nobody really wanted to say, okay, I'm guilty of having set up that access point. In one case, we found the access point that has been forgotten. It was an access point in a hospital that has been installed sometime there, and it had simply been forgotten, and the IT guy was really surprised to find it.
And a friend who's doing a similar project in Wisconsin, and he discovered a hospital nearby that had, I think, an OC12 or some very high, effectively he was 10 milliseconds away from above net. And he has better network connectivity wireless out his window than he does paying for an ISP. Anybody who lives in Cupertino, which is the middle of Silicon Valley, Apple computers is all over that area. Another friend of mine, his AP got unplugged by accident because he knows he was getting better bandwidth. Anybody who lives near Apple campus buildings, Apple is a wide open network. If you have an apartment near Apple, you have free internet access. They actually know about this, actually put things off in a separate DMZ. I don't know about around here, but in San Francisco, more and more coffee shops are opening up for free access. Yeah. One thing I'd like to point out is the legal problems of this. There are lots of places that are opening up free network access. BWUG, Bay Area Wireless Users Group, their purpose is to open up and provide for free networks. Get them in here. Hopefully our wireless LAN will work at decent speed. What I just popped, what's coming up in a second is Bay Area Wireless Users Group sets up free LANs. Now there's a huge question here. What happens if you're at a coffee shop or using one of these people's actually free LANs, and you turn your back for a second, or you walk 10 feet down the street and you switch onto a corporate LAN? Your card may very well switch over to a corporate LAN. Now you're not trying to be malicious, you're just checking your mail, but you're now violating the law by trespassing on their network. But you don't know this.
the interesting thing is that at least for Germany, the legal situation is quite interesting, as the legal people say, because wireless LAN is working on 2.4 gigahertz, which is an unregulated frequency. So that means receiving and or sending on that frequency, as long as you keep below 10 milliwatt, is legal in any circumstances. There's no regulation whatsoever. And that violating the computer criminal law in Germany requires to trespass in visible security measure. So if I walk down the street, get into a network and have internet access there, I'm not violating any visible security measure because the network is simply invading my laptop. I can't do anything about it because it's in default configuration. So I'm still waiting for the first case that is going to be in Germany, but I really doubt that there is someone getting prosecuted for that. So the networks that you're going to see are really wild. Normally you're looking not into a DMZ, but into the real internal network. You're looking into the intranet, especially at trade fair shows like CeBIT. It was more or less the starting point for war driving here in Germany, because a lot of people were walking around the halls and looking for internet simply to read their mail and click some web, and found themselves inside the intranet of real big companies. And so that started more or less the trend in Germany, and we found, except from the hospitals that we hopefully have nailed shut now with the help of the Datenschutzbeauftragte, we found a lot of companies like radio stations, breweries, and all that kind of stuff that have their networks wide open. And simply the number of systems that you have found, it's far below what Pete has in San Francisco, far below. But even that number prevents us from calling anybody and saying, okay, your network is wide open, because it takes half a day until they understand. Yeah. So my point of ethics is saying, okay, if people are invading me with their networks, well, it's their problem, not mine.
Okay. Well, I don't know much about European law, but in the US, a lawyer is obligated to keep your information secret. It's something called client attorney privilege, where they're not, so when I talk to my lawyer, that's a confidential agreement that even the government can't peek into. But when I walk down the street in San Francisco, I find wireless networks belonging to basically lawyers and barristers, which means I could, with click on my computer, click on computer networks or my network, my computer network, and I actually see their file servers. You see casing briefs of what files and what they're going to do tomorrow in court. Yeah. There's a clear violation of people's privacy.
Yeah. And that's a little bit difficult. So in the case of the hospitals, we reacted and wasted our time just trying to get these hospitals shut, because this is personal and private data and medical records and potentially life endangering. So we feel that that couldn't be tolerated, and we couldn't just simply walk away and leave it that way. But in the end, we have so many networks out there and so many potentially dangerous networks out there that there is no one that can simply do their job of scanning all these networks and notifying their owners. So we tried the public approach, trying to get some articles into the media about it, but that didn't even help either, in no way. So, and the majority of things that you're finding out there, at least in Germany, are airports that are connected to DSL lines and just switched on and left there. And so one positive aspect about it is this wavelength stuff is giving you the possibility to do anonymous publishing. Because you can, if you need to upload some little bit risky file to the internet for publishing, you just walk down the street, get an open wavelength network that you're never going to visit again, and upload your file, and that's it. So that's opening up a tremendous possibility for things that have been become difficult with the advent of digital telephony and easy identification of users on ISPs. So, questions, comments?
Came in here for a reason. Microphone?
You've spoken about the owners and operators of these networks, the corporations, the lawyers and the hospitals, who might be hoped to have an interest in their security. But aren't the people who really have the greatest interest the end users, the people about whom the data is referring to? Do you think there's any scope for pursuing the issue by actually identifying individuals who are referred to in this data and getting them to pursue the matter? because after all, it's a breach of their privacy.
One of the things that we found in Berlin was in a private hospital. It was the most expensive private hospital in Berlin, and they had all this kind of high-ranking people being treated there. And it took us nearly a week until they finally shut down their airport station.
I've actually had pretty much the opposite view. About 3 or 4 years ago, I war dialed the entire Bay Area. I called over 5 million phone numbers and did some statistics on that. And what a lot of people I found a lot of doctors' offices that are wide open. I actually called up these doctors' offices. They didn't care. Quite literally, I know of several pediatricians and actually one sex clinic actually has a wide open dial-up for the information database. I've notified them. I've told a friend who's a reporter, my friend Simpson Garfinkel, who wrote an article on this. He called them up and left messages in no uncertain terms what the problem was, and they still are wide open.
Yeah. So that was quite, for me also, a quite interesting reality check in how security consciousness normal system operators are. They are not.
Want a video link?
I have a couple questions about this. Of course, one is, I think everyone knows that I started a company to develop these things, but one thing I could never figure out is I suggested using a cryptography, strong crypto, to make the spreading signal. And these waveland cards and unfortunately Prism cards use a simple polynomial, which just simply doesn't work. And the other question is, hasn't anyone heard of SSH?
Well, effectively, eventually going to get to this, but if you have a wireless network, what I recommend you do is you place your wireless network on a DMZ, put it on a locked network. And the router or the firewall you're using to set up the DMZ, configure it for IPsec, and then have all your laptops, all your wireless gear, simply run IPsec over your wireless LAN into your firewall or router, and then everything's taken care of for you. Assuming that people are not going to find your network is not going to help you. Assuming that you're using WEP and that's not going to be broken is not going to help you. Based on what type of WEP you're using, it can be broken as little as 30 seconds. So for the most part, WEP can be broken between 30 seconds and 4 hours these days. So effectively, you have no real choice but to use IPsec. Anybody who's on a LAN, assume you're on the LAN here at HAL. You're in a LAN where people are going to be watching your packets, recording everything you do, use SSH, use encryption. Assume that your wireless LAN is as open as the internet, because it is.
Further comment is if these wireless cards use a cryptographic spread spectrum, one is you can transmit on any frequency you wanted to. There'd be a lot more bandwidth available, and you'd be invisible because no one would know where you were transmitting at any particular time.
Yes, we would know where you are, because if my cards be compatible with the network, I'm going to have hardware that can actually figure out the spectrum distribution. Thus, anybody for $50 can pick up a piece of hardware that will do the spectrum.
But you must get fairly close to the source to actually see it.
The card will automatically associate. Another big problem is even if we do change the cards to use a different frequency and we do change the encryption, there's still a grotesque amount of legacy hardware that's going to be out there. All the networking hardware that's already been sold today is going to stay in use. It's not going to go away. So if IEEE was to release a new 802.11 spec this moment, and all the manufacturers were to adopt it, we would still have this open security problem for years to come based on legacy hardware.
Okay, I agree with you that 100%. It's just that when I set up my own network, I want to do it right. That's all.
Well, you can always go with Homeland. I think that's a dead protocol nobody's going to be looking for.
What?
Intel, there's a competitor to 802.11 called Homeland, which isn't as robust and is pretty much on the way down right now. But you can always buy that hardware really cheap, and I don't think people will find you. Either that or use for old frequency hopping, so, 802.11 with the frequency hopping.
And if it hops
I don't think
around
anybody's
places,
looking for that stuff.
if it's fast frequency hopping, faster than the data rate, say hopping 100 million times a second, they'll never find you.
Also, there's wait for 802.11a, which is going to be the higher speed at a different frequency. Then, of course, we'll do the same thing again, but it's a little bit difficult with the higher frequency. Any other questions? Questions, comments, insults? Fruit, vegetables? Is everybody still hungover from last night?
So is anybody of you telling the story of war driving, being around, finding interesting stuff?
I got one. Everybody here familiar with Chubb security? You know, the guys that the people your boss pays to hire you for security guards, locks on your door, your fire system in major buildings. You know, Chubb. Well, I was in London about a month ago, and I got a little bit bored, so I packed a parabolic dish with me, and he pointed out my friend's window. And sure enough, we were on their internal LAN. This is like one of the most old business, big security companies out here in Europe. And they had an open wireless LAN. The entire MIS and accounting, all their documents were wide open. I was a half mile away from them, but I had line of sight out the window of my friend's apartment, or my friend's house. And I literally popped up my laptop, turned it on, sure enough, I was on their LAN. And I had full access to everything they had. And this is a security company. Driving around Sunnyvale, every firewall company, seriously, every firewall company, Checkpoint, Cisco, all of them have offices in Sunnyvale with wireless LANs that are vulnerable. No encryption, pull your car over and hack. Check your mail, whatever. It's all wide open. When it comes to denial of service, there's a whole new breed of denial of service. Those familiar with routing protocols, if you insert a bad route to a map, it propagates. BGP is really bad about this. So, as I'm driving around, one of the most common things I see are ARP requests, which every network is flooded with, and BGP broadcasts. What if my laptop was to respond with a better route? Your network would just stop working. None of your packets would be able to get anywhere. And your sysad will never figure out what the hell happened.
Another thing of the nerve serves that there are certain brands of base stations are susceptible to buffer overflow attacks in the password entry. So trying to send long passwords to, for instance, lucent base stations is quite an interesting idea. And normally they are stopping above 35 characters. So the thing is, this infrastructure is incredibly vulnerable in itself and for the companies that are using them.
Question?
Well, a remark. I'm from the wireless team here at HAL, so we have some experience here when we built this network. A few things we noticed is that the most problems came from people who put up their own base station. Usually they added the DHCP server. We were lucky we could trace these people more or less in a straight line with a directional antenna. We noticed that yesterday the network was gaining like the most load it could carry. So people were more eager to put their own base stations there. Again, we found them and removed them. Then people started to become really smart, like let's make a closed system so that we can have wireless and the others, well, it's full. Those are more difficult to track because if it's a closed system, how do you get on it? So we had one Prism card to locate, to see the raw frame so we could see the ESID. Then sometimes you could get on it, sometimes you couldn't get on it. If we couldn't get on it, we would go into ad hoc mode, pick the channel of the base station, and see where we lose the signal most. So our disruptor guy was walking, and he could actually find them that way. So it's ad hoc mode is really killing a network like this, I noticed.
Yep. So one question, why didn't you publicly assign one channel for private base stations? That would have solved the problem. Because it was obvious that people will bring their own base stations and saying, okay, and printing in the manual saying, okay, channel 11 or whatever is for your own base stations, don't go to other channels, would probably have diminished the problems of wide base stations.
Well, people were too closely packed, and we tried to stay away from channel 1, which is the default Apple Airport one. But we just got problems anyway. We were using up all the frequencies. Yeah. I think if we would have had more directional antennas, we could have made better cells.
Yeah, another problem with 802.11 is that the channels themselves are too close together. So when you're setting up base stations, you want to skip every other channel just to make it work better. In addition, one of the biggest mistakes people have when they set up their own network, they don't realize their neighbor has one, so they both set up on the same channel and they wonder why they don't get the bandwidth.
Well, yeah, also we got a bunch of different cards, so we couldn't use all the channels.
They don't.
So there were also like French cards which only have 4 channels, so at some point we were limited with the channels that we could use on our access points.
They have some maps they would like to show us. So.
Well, it's just different maps. This is how just walk from our tent to here, and there are some different Rook wavelines here at HAL. but I think everybody already noticed that. It's distorts the signal quality quite a bit, I think. This is the application in its waveless finding mode. The green circle is just where we are in the main tent. The GPS works very well inside this tent, and you can see down there the different base station we find. It's a line starting with the W, and it should see different MAC addresses depending on where he points the antenna to see the different base stations.
Trying to.
It should. If it doesn't, then okay.
Oh, we have at least two different.
Okay, that's a different one. It's C8 at the last octave. Okay. What? Oh,
Oh,
where is it?
we are done. Why don't you say something?
No? Wait. Low tech. So, now. It's back there. Basically, it just logs all the coordinates into a file, so we can do better analysis later on. But it's already okay to see when you're driving around, see where you are, plan your next route. We've already done this in different cities like Stuttgart and so on. Just grab the map somewhere, either from the Landesvermessungsamt maps, or this is from Map Blast, I think. They have some pretty nice maps, and we have different. We've put different maps to use.
I can hook you up with some pretty good map databases.
What?
I can hook you up with some good map databases.
Yeah. We've. I can show you something.
Oh wait, another toy in the software we have allows us to upload the. We take all the data. We basically I distill it down to the strongest signal point, or I use triangulation, and then we upload it back into our GPS as waypoints. So it's great. It's really it's really not that applicable in the sense that really it's a good show-off toy. You just pull this little GPS out of your back pocket, turn it on, and there's like click on a waypoint. There's an arrow pointing to the closest waveland available.
There's something like Stadtplandienst in Germany, which has pretty detailed maps. They have it in little 195 pixel times 195 pixels images on their webpage, and you can download them and merge them into a big picture, which is a little bit too big for this laptop, but it should work anyway. They don't like it if you do this. They actually sued a friend of mine for downloading some of these pictures and displaying them somewhere, but I don't think they will notice if I do this here. This is a really detailed map, so it takes. You actually see that the waveland points are quite a little bit space of them between them, because the waveland card doesn't scan that fast, to at least ours. If we scan faster than every 3 seconds, it doesn't really work very well. So if you drive with the car, you have to watch out that you're not too fast.
Yeah, this is actually the waveland we use to download these maps without getting sued, because we assume that it's safer to use an anonymous network.
Okay.
So we downloaded all the cities.
Yeah, it's not too much. This program will be made available, but I'm not sure if this is the best program. He has some pretty cool software too.
Yeah. Wait about 2 months, and when these guys work for a little bit, we'll have some really nice stuff for you for FreeBSD.